has a few questions on transformations and analytical geometry. Well, let's see what they give us. They say ABC is an isosceles triangle. ABC is isosceles. Okay, we can see that these two sides will be of equal length. They say AB is parallel to the x-axis. That means AB is parallel to this line. Okay, and AC is equal to square root 10 units. So AC, this distance here, square root 10, which means that this is also square root 10 because they are isosceles, same length in an isosceles triangle. Okay, so that's that for this page. Now let's see what the questions are. 8.1. Rigid transformation applied to triangle ABC to obtain triangle PQR as shown. Okay, so from here to here is a rigid transformation. That just means that the size and shape of the original object does not change. So rotations and reflections and transformations, those are rigid transformations. Okay, describe the transformation in words. Okay, so something that's important here is to match up the order of the letters here. A, B, C, P, Q, R. A, B, C, P, Q, R. Okay, so that means it has not been reflected because the letters are in the same order as they relate to each other. Okay, so that means the only thing that could have happened here is either rotation, and if it was rotation, we'd have it being inverted, with the top at the bottom and the bottom at the top. So this is clearly a translation, just a movement to a different spot. So now we have got a point C and R that relate to each other. So all we need to see is how much the x value has moved and how much the y value has moved. Okay, so we know from C to R. So from C to R, we had 0, 1, 0, negative 1 to negative 4 and 3. So what does that mean? Well, that tells us that we moved from x and y to, okay, so from 0 to negative 4, we had to minus 4. So that was our original value, minus 4. And from our y, we had from negative 1 to get to 3, we had to add 4. So it was y plus 4. Okay, now with our x values, that tells us the movement sideways, and the y values tells us the movement up and down. So x minus 4 tells us we moved 4 units to the left. And we said this is a translation, right? So it's a translation of 4 units to the left and up or down, y plus 4, 4 units upwards, and 4 units upwards. There we go. 8.2. Triangle PQR is reflected about the line y equals x. Determine the coordinates of r prime. Okay, the triangle PQR is reflected along the line y equals x. So that's a line running like this at 45 degrees. Okay, so this would be a mirror line for this one to reflect in. But this equation is even simpler than visualizing it, although it's nice to visualize all questions. So they said this triangle is reflected about the line y equals x. So if we had an arbitrary point, let's call it point P, and we had P being x and y, if we reflect that along the line y equals x, then its reflection would become, well, if we know that y equals x, then x equals y as well. So what our x was, our x would now be a y, and our y would now be an x. Now let's just apply this simple logic to our original r value. We had r is negative 4 and 3. So we start off with r being negative 4 and 3. Now what would r prime become? Well, again, we know y equals x, now x equals y. Start off with x being the y. So our new x value would be the original y value. which is 3. And our new y value would be our original x value, which was -4. Just as simple as that. When they give you a reflection in across some line, you just apply that equation to your original x and your y values to find the new ones. Okay, 8.3. Triangle ABC is enlarged through the origin to obtain triangle A prime B prime C prime, such that the area of the new triangle divided by the area of the old triangle is 16. Now, 8.3.1, determine the factor of enlargement. Okay, now let's just think about this for a little while. This has to do with the area. They say the area will become 16 times as much. Okay? So now what would the an area consist of how many dimensions? 2 dimensions, right? It's the length and the breadth, or however you want to see it, but it's a sideways, I don't know, it's an x and a y coordinate point. So 2 dimensions that we're working in. Whereas a factor of enlargement is only 1, it's only along the original lines. So therefore, the area increases by the square of the factor of enlargement. Okay, the area increases by the square of the factor of enlargement. Now if we were to work out the volume, let's just think about that, then we'd have 3 dimensions. We'd have a left, right, an up, down, and a depth dimension. So that would be then the cube of the factor of enlargement. Okay, so if we know that the square of the factor of enlargement is 16, so let's just say the factor of enlargement equals x. Okay, we want to work out the factor of enlargement. We know that the square of the factor of enlargement is equal to 16. Okay? So we know that the square of the factor of enlargement equals 16. Therefore, let's take the square root on both sides, and we've got x equals plus or minus 4. But the factor of enlargement, in this case, it's going to give us something that's bigger, not something that's smaller, so we're only looking at the positive. So the factor of enlargement is 4. And there's your answer. And again, if it was cubed, we'd look at the cube root to find the factor of enlargement. If this was a volume question, not an area question. But it isn't. 8.3.2. If AC equals square root 10 units, which we saw in the picture, write down the length of A prime C prime. Okay, well AC is part of the original triangle, so triangle triangle ABC, that's the original triangle, and the new triangle is triangle A prime, B prime, C prime. And we said the factor of enlargement from here to here is 4. So 4 times the original one is equal to that one, right? So each distance, the distance between AB, between AC, and between BC, all have to be multiplied by 4 to be equal to the distance between A prime, B prime, A prime, C prime, and B prime, C prime. Okay, so the original distance between AC is square root 10. So now we know that for the new triangle, the distance between A prime, C prime will be equal to 4 times the distance between AC, and that is equal to 4 times square root 10. That's your answer. In this case, a very short description. Okay, last question for number 8. After a rigid transformation, again rigid, no altering of the shape or size, either reflection, rotation, or translation. Rigid transformation is applied to triangle ABC to obtain triangle DEF. F, which is 0 and 1, is the image of C. If E is the point S and T, write down an equation in terms of S and T. Okay, let's just compare the original to the new triangle here. Original triangle ABC and the new triangle DEF is not shown on here, but we can imagine what it is. So ABC would mean DEF in that order. So somewhere we've got a triangle DEF. So if we had our original triangle, let's call it A, B, and C, and now we've got a new triangle DEF. Okay, so they say the point F is the image of C, and C was 0 and -1. Okay, C was 0 and -1. F, they tell us, is 0 and 1. Okay, so now we can see how it has moved from there to there. Now they ask us to write down an equation in terms of S and T. They also tell us that point E is ST. Okay, write down an equation in terms of S and T. Well, we can, because we know that, because isosceles triangle has equal sides here, we know this was square root 10, so this distance is also square root 10. Now we can know that because it's a rigid transformation, this distance is also square root 10. But how do we calculate the distance? Remember, we'll use Pythagoras Theorem, and we'll say that the distance EF squared is equal to, let's just pretend we had a vertical line down there and a horizontal line here. So this distance squared is equal to that distance squared, which is our y value, right? T. So that's T, and this distance squared, which is S. Okay, so we have this distance is S minus 0, apologies, and this distance is T minus 1. Okay, so we'll have that is S minus 0 squared plus T minus 1 squared. Okay, so we'll take the square root of both sides, but we also know EF squared is equal to CB squared, which is 10. Okay, so square root 10 squared is equal to S squared, which S minus 0 is just S, you square it, you still get S squared, plus T minus 1 squared will give you T squared minus 2T plus 1. Okay, so now the square root of 10 squared is just 10. Okay, let's just rewrite this and collect some terms. S squared plus T squared minus 2T plus 1. Okay, we want to just make this side equal to 0 and say S squared plus T squared minus 2T plus 1 minus 10 give us minus 9. We've got an equation in terms of S and T, exactly what they asked for. And that's it for question 8.